Hi everyone, I am Leah Pueblo. My report is all about speed measurement, but we will focus only the linear speed measurement. But before we proceed the formal discussions about the linear speed measurement, um, we we identify that what is speed measurement. So speed measurement was introduced to measure the distance traveled by an object per unit of time. This is for the example of this is for indoor and off-way vehicles, conveyors belt, material flow. So, for example, to measure the speed measurement is you are driving a bicycle. So, for you to able to know if pila ang gikos kun sa imong pagpadalagan is naa siya speedometer and odometer. So, those instrument makabalo ka kung sa usang gikusgon ang imong pagpadalagan. So those are the example of speed measurement. And we will proceed to the linear speed measurement. Linear speed measurement is the measure to the concrete distance traveled by a moving object. The speed with which an object moves in the linear path is termed linear speed. So in easy word, it is the distance covered for a linear path in the given time. So for example, ang sayang gikos for example are driving a bicycle. So diri nimo ma-measure ang iyang pila ang iyang linear speed through a certain of time kung pila ang gikusgon niya sa iyang pagpadalagan. So we have a concept of linear speed. So the linear speed of a point of an rotating object can be determined by its distance from the center of the rotations. So the angular speed is measuring the angle that an object travels through a certain amount of time. The angular speed will measure in units of radians per second. For example, radian per second. Those are the concept of linear speed. So here is the formula of linear speed. Now we can compute linear speed as V is equal D over time. So V stands for linear speed, D stands for the distance, and T stands for time. So linear speed, this is the formula of linear speed to get the exact average of linear speed. So linear speed times the angular speed, which is this is the sign that stands for angular speed, radius of the rotation. So V stands for the linear speed, so meter per seconds. Omega, this is what we call omega. This symbol is what we call omega, is the angular speeds or radian per seconds. R is the radius of the rotations. So I have some examples that in order to understand on how to compute linear speed measurement. So here's the examples. The power wheel begins and revolving at 10 revolutions per seconds. The diameter of the wheel is 4 meter. What will be the linear speed of the point of the wheel on the surface in meters per seconds? To solve the examples, example number 1 is we are finding the linear speed of a point of the wheel on the surface in meter per seconds. So first we start to find the angular speed. The revolutions per second must be converted to radian per second. There are 2 pi radians in a circle. So this means that so this is the formula. So v velocity is equal to omega times r. So but before we proceed to this formula, we have to find first the angular speed. So the angular speed. So we have in our we are needed to convert the revolution. So we have revolutions per seconds So, kinahanglan siya natong i-convert into radian per second. So, the first thing we do is, ang pangutana, unsaon na to pagkuha sa angular speed. So, ang angular speed is, we are given a 10 revolutions per second. So, ato siyang i-convert into the radian per second. So, we all know that we have a 2 pi radian in a full circle. So, to solve this is, we have 2 pi, we have 2 pi radian. Ato siyang i-multiply into the 10 revolutions. 10 revolutions. Revolution per seconds. To cancel out this is, we have to add this. 1 revolution. Have to 1 revolutions. Cancel out na to. Ang mabilin is rad per seconds. Cancel out na to. This 2 is mabilin. So, 2 pi times 10 revolutions is 62.8. So this is the answer. This is our angular speed. So we will go back to the continuation of these examples. So, and the radius is, and the diameter of the wheel is 4 meters. So we have to divide it into 2 because there are 2 pi in the radian. There are 2 pi in a full circle, in a full circle. So 4 divided 2 is equal to meters. So nanatay angular speed and nanatay radius. So we'll proceed to the next steps. This is the formula. Velocity or the linear speed is equal to the angular speed times the radius. So we have ang angular speed is, this is our angular speed 62.8. So we are ibutang diri ang 62.8 radians per seconds times the radius, which is 2 meters. To multiply this, the answer is 125.6 meter per seconds. Meter man. So, meter per seconds na siya. So, the answer is the linear speed of a point of the wheel is around 125.6 meter per seconds. So, we will proceed to the example number 2. The body starting from rest moves with the acceleration of 5 rads s2 in a circle of radius 3. Compute the linear speed after 5 seconds. So, this is the answer. We are given the acceleration is 5 rads s2. The radius is 3 meters. And the time is 5 seconds. So, this is the time. So, to get first the angular speed is, we compute this like this. So, angular times 0 plus acceleration times acceleration and the time. So, to put the given of this is our angular is unknown, so we put the 0 plus our acceleration, which is 5, and the time is 5 seconds. So 5 times 5 is equal to 25 rods 1. So this is our angular velocity. So next, we'll proceed to the next steps. So to get the linear speed is given by velocity times the angular times r. So we already know that we have already an angular speed, which is angular velocity, which is 25 rods s1 times the radius, which is 3. So this is the radius, 3 meters. 5 meters. So 25 times 3 is equal to 75 meter per seconds. This is the answer of example number 2, which is the 75 meter per seconds, the linear speed after the 5 seconds. So our next topic is revolution counter and timer. So what is revolution counter and timer? But before we tackle about what is revolutions counter and timer, I will show you a pictures, a mechanical tachometers that are using to measure the revolutions counter and timer, that we are using revolutions counter and timer rather. So this is the picture, this is the mechanical tachometer. So these are the examples of this is what we call the revolution mechanical tachometer, but we can measure the revolutions counter, including the timer. So revolutions counter is used to measure an average speeds of rational speed instead of instantaneous rotational speed. So it consists of a worm gear that is usually attached to a spindle. It has 2 dials, the inner and one and the outer one. So the inner dials represent 1 revolutions of the outer dials, and the outer dials represent 1 revolutions of the spindle. The tachometer has a stopwatch attached to the revolutions counter, and it is used to indicate time. These are limited to show engines and measure satisfactory up to 2000 to 3000 revolutions. This is represent as revolutions per minute. So here's the parts of the tachometer, which is we have the handle, the lock, the worm gear, shaft attachment. This is the shaft. This is the shaft attachment, and also this the shaft. Dere natin insert ang shaft para ma-compute na to ang iyahang revolutions. This is the spar gear, and this is the pointers connected to the dial. This is the dial on frame. This is the hole is the casing. Unsay mga functions ani nila, so we will discuss this. So the working of the working of this is the worm gear is driven by the speed source. So this is the worm gear. So once they are rotating, they are also driven by the spar gears. Rotate po siya, and the pointers will point to the dial or start pointing to the dial on frame, which is dili na tumabalaan kung pila ang iyahang revolutions. So the rotating worm gears drives the spar gear, which is turned actuates the pointers to the dial. So like what I said earlier, that once nga mo rotate ni siya, they are connecting this. So once mo rotate ni siya, and the pointers will mohatag na siya og giving an accurate speed on a dial frame. So this is for example, dito siya may siya mga number din na tumabalaan og pila ang iyahang revolutions. hence indicating number of revolutions in certain span of time. These functions requires a separate timer, so they are needed a separate timer because para mabalaan nato kung unsa jud na para makuha nato ang accurate average and measuring the revolutions counter and timer using the counter and timer. The revolutions counter does give an average rotational speed rather than instantaneous rotational speed. So we'll proceed the next. The revolutions counter and timer start simultaneously on contact with the driving shaft. So like what I said earlier, once the shaft will starting rotating, that will inserted into the shaft attachment of the tachometer or mechanical tachometer, which is this. They are starting rotating also this, the worm gear, and including the spars and the pointers will start moving this to give an accurate revolutions. Simultaneously means dungan sila tanan. The entire assemble functions as so long as the contact is maintained. The rotation is calculated from the individual readings to the counter and timer. So this means that the revolutions counter start counting, and also the timer will start if example 1 minute. In 1 minute na siya, let's assume that in 1 minute na ay siya 60 revolutions. So but what I suggest is to get the accurate average speed of an engine, which is you are needed to if kasa lang nato i-count ang trying to measure the revolution is dili siya insakto nga mo what we call this dili siya insakto o dili ta ka-assure nga mao na gyud ang ihang average speed of the engine. So we will do it twice or 3 times ba. So let's assume I will show you some solutions in order to get the accurate speed engine of these mechanical tachometers. Hence we are using the timer for finding the speed, so I will show you some solutions in order to get the average speed of an engine. So let's assume that the timer start and the shaft will start rotating. So for example in 1 minute, for example in 1 minute they have 60 revolutions. And in another let's assume that the timer will start again and the shaft start rotating also. So the what we call this the pointer start moving in the dial on frames, and they have in 1 minute they have a 59 revolutions. So in another 1 minute they have a 59 revolutions. You have a 59 revolutions to assure that to get the accurate speed of an engine is we add another 1 minute. We add another 1 minute is, and they have a 61 revolutions. So this is the hour. You are using the revolutions counter and timer. So this is the timer and the counter. So in 1 minute, they first they are starting. We are starting to count. Is in 1 minute they have a 60 revolutions. In another 1 minute they have 59 revolutions. And the third is they have in 1 minute also they have a 69 revolutions. To get the average speed of an engine is we need to add this, and the result is 60 plus 59 plus 61 is equal to 180. So 180 we are divided into 3 rather, 3, and the answer is 60 revolutions per minute. Revolutions means this is the revolutions. Where you nganong nainang the question is nganong nahimo siyang revolutions per minute, because we are we are measuring in revolutions and in minutes man. So we have to write this is 60 revolutions per minute. So this is the 60 revolutions, but we are we are making into the revolutions per minute because minutes man atong gigamit. So that's the example of revolutions counter and timer. I have videos that I will show you to in order for you to understand clearly what is the functions of revolutions counter and timer.
Today's class we will discuss one of the mechanical tachometer, it is revolution counter and timer. This revolution counter and timer tachometer is using for finding the speed of the engine or speed of the turbine or speed of the compressor, like that. Okay. So it is using for finding the low speeds, RPM. RPM is revolution per minute. So here we are using revolution counter tachometer and also timer also for calculating the time for the revolution of the speed of the shaft of a given engine or any turbine or compressor, like that. So what is the basic principle of this tachometer and which principle it is working? Here we are using the mechanical force and the mechanical parts for finding the speed of the engine. Okay. So here take the description of revolution counter tachometer. Here this is as shown in the diagram. In this diagram, okay, this is one casing. Okay. Actually, if you are taking cross section of this casing, okay, we are removing the casing. So inside part of the tachometer are one shaft. Okay, it is moving either clockwise or anti-clockwise. Okay, and on it one gear, worm gear is mounted. Okay, this worm gear has teeth like this, and these are inclined teeth, and this worm gear is mounted on the shaft. So when shaft is rotating, this worm gear is also rotating. Okay, and here one handle is there at the end of the shaft. If you are moving this handle in one direction, it is moving forward, this shaft is moving forward. And if it is rotating in reverse direction, the shaft is coming back, okay, in this direction. So it is moving linear direction whenever we are operating the handle. And here this worm gear teeth has connected to one gear, it is called spur gear. Okay, on spur gear also it is a circular one. Okay, this gear is linear, this spur gear is circular one. On it some teeth are there on the surface. Okay, on the entire surface teeth are there. This teeth is connected to the worm gear teeth. Okay, and here this gear is connected to one shaft here like this. Okay, if gear is rotating, this shaft is also rotating. Okay, and here one pointer has connected to the shaft at the middle, this pointer. Here one dial gauge is there, circular scale, we can call it as dial or frame also we can call, or dial on frame. Okay, this is the frame, on it some circular scale is there. Okay, like this. Now this, whenever this gear is rotating, this pointer is also rotating. Okay, and it is showing the reading on this gauge or dial gauge or circular gear, circular scale. Okay, this shaft should connect to the input shaft. This is called input shaft of the engine or turbine, like that, or compressor, whatever we have to find the speed. Okay, let us take, we have to find the engine speed. Engine shaft we have to connect to this tachometer. This is a tachometer, revolution counter tachometer. We have to connect this shaft to this shaft. Okay, so here how to connect this? By operating this handle. Okay, we can connect this shaft. If it is rotating, this way, this shaft will also rotate whenever they are connecting with each other. Okay, let us assume it is moving counterclockwise, it is also moving counterclockwise. Okay, whatever speed it is moving, the same speed it is also moving. In this description we are using here one lock. Okay, because by operating this lock, let us assume we are operating in this direction by using hand. Okay, this gear and this gear will meet. If we are operating in the opposite direction like this gear will move away from this gear. This gear will not meet this gear, means there will be some gap between gear and this gear. And so by operating in opposite direction, this gear and this gear will get gap. Okay, and if you are operating in this direction, this gear and this gear will connect like this. Revolution and counter and timer also we are using for calculating the time for how many revolutions per minute, like that. Okay, so this is watch for we are using in this tachometer. Let us take the operation of this tachometer. Here initially by using the handle, we have to give the forward movement for this shaft and we have to connect the required engine shaft. Okay, when the engine is running, this shaft is also rotating. If this shaft is rotating, this worm gear is also rotating along with the shaft, and this will try to rotate the spur gear. Spur gear will also rotate. If spur gear will rotate, the shaft we are connecting to the spur gear at the center, it will also rotate. If it is rotating, the pointer connecting to the shaft will also rotate. Okay, and it is giving the reading on the dial scale. Okay, so in this process we can find the speed of the engine, whatever we are connecting here, turbine or compressor, we can find it. Okay, here one more important thing is, here we are using the timer for finding the speed. So let us take this marker initially is at 0. Okay, let us take the timer, it is the watch for calculating the time. Okay, start the timer and start this speed. Okay, now let us take in 1 minute in the timer, it is moving 60 revolutions. Mark it for the first time, in 1 minute it is making 60 revolutions. Stop the timer. Okay, and then after that again for 1 minute, how many revolutions it is moving, again take it. Okay, for a second time in 1 minute, let us assume it is showing again 59 revolutions. Okay, again for next 1 minute, it is, let us take, it is moving 61 revolutions. Like that we have to take 3-4 readings or 4-5 readings. Okay, take the average. Average means sum of all this divided by number of times we are doing. Let us take, it is in the first time it is moving 60 revolutions, next time 59, next time 61. If you are taking average, it is showing 60 revolutions. Now we have to take the average speed by using this tachometer. It will give the correct value if you are calculating the average speed. The meaning of this is, the average speed of the engine is 60 revolutions per 1 minute. Okay, so here the answer is 60 rpm, 60 revolutions per minute. Like that we can calculate the speed of the engine or turbine or compressor by using the tachometer and timer. Okay, so here always remember, this tachometer revolution counter will give the average speed only correctly, not the instantaneous speed. If you are taking at one time, it may not show the correct reading. Okay, always remember, it will give the average speed of the engine. And we are taking the applications of this tachometer and timer. It will give the low speed of the engine correctly. Okay, low speed of the engine. Engine will give correctly. Okay, and the speed is in between 2000 rpm to 3000 rpm. Okay, so this range it will give measure correctly, 2000 revolution per minute to 3000 revolution per minute. And what are the advantages means, it is using for finding the speed of the engine, shaft or compressor. And here this is the simple arrangement. Okay, and if you are taking disadvantages or limitations, the gears we have to check every time, okay, whether these are lining properly or not. We have to check the gear arrangement properly. And we have here so many mechanical parts are there. We have to give the lubrication oil for the smooth movement of the engine or smooth movement of the tachometer. And then here we have to connecting to the shaft to the input, so more noise will come. It is one of the limitation of this tachometer compared to the electrical tachometers. This is the revolution counter and timer tachometer. In next classes we will see some other mechanical tachometer. Keep watching.